In this video, we are going to find a polynomial function with real coefficients given the degree of the polynomial plus a partial list of the zeros. So we are in particular going to do number 24. This is of degree 5, our polynomial that we're looking for, which means that there will be at most 5 unique zeros. So as of right now, it looks like we have 2 zeros, one of multiplicity 3 and another 0, 1 plus I, which really means that we have 3 of the zeros right here to a certain extent. So we have 4 total, so we need to find one more 0. And to be honest, it's actually very easy in this situation, because one of our zeros is complex and we are told that our function has real coefficients. If you have a polynomial function with real coefficients and one of the zeros is complex, then the conjugate of that complex zero will also be a 0. So since 1 plus I is a 0, so is 1 minus I. And so we can actually write out our polynomial. We'll call our leading coefficient A. They don't tell us what our leading coefficient is, and they say that answers will vary depending on the choice of the leading coefficient. We'll just keep that as A for our purposes. Since we have a 0, 1 of multiplicity 3, if 1 is a 0, that means x minus 1 is a factor, and since it's multiplicity 3, we will put a 3 as the exponent. And in fact, I'll just highlight this so you can see where each of these come from. This comes from here, and multiplicity 3 is what gives us this 3. Since 1 plus I is a 0, that means x minus 1 plus I is a factor. And I like to start at least by doing x minus, and I keep the complex 0 in a parentheses at first, and I'll clean that up later. Since 1 minus I is a 0, that means it'll be x minus, and again, parentheses 1 minus I. So we have the beginning of our polynomial, but we need to clean it up. I'm going to distribute this negative sign, so it becomes x minus 1 minus I. Remember, if there is a negative sign outside of parentheses, what happens is whatever's inside the parentheses, the signs change. So both positives become negatives. And in the second example, or the second parentheses, the positive 1 becomes negative 1, the negative I becomes positive I. Now we are not done because we need to find a polynomial function with real coefficients, and we don't have that yet. So we are going to multiply out, in particular, these two polynomials, these two factors. I'll start by multiplying everything in the right parentheses by x, so that'll be x squared minus x plus xix. Then I'm going to multiply everything in the right parentheses by negative 1, so that's going to give me negative x plus 1 minus I. And then I'm going to multiply everything in the right parentheses by negative I. And that ends up being negative ix plus I, and then this will be minus I squared. I'm going to combine my like terms. Notice that some of these things will disappear or cancel each other out. This ends up being x squared minus 2x. And remember, negative I squared is equal to basically negative 1, which is positive 1. So I'm going to combine positive 1, and this is also positive 1. That'll be plus 2. And at this point, we have ourselves a polynomial in factored form that has real coefficients. This, I think, is a perfectly acceptable answer. All right, I hope that was helpful. Have a good rest of your day, and we will see you in the next video.